Good afternoon, guys. I just wanted to go through a couple of these examples on the practice assignment number one. Some of you guys are submitting your work, which is great. And I just want to go through some of the common mistakes that I'm starting to see already. So hopefully the rest of you, before you submit it, can look at this and try to correct those. So I'm going to try to do like one or two examples from each little section, and then give the rest for you guys to do there. So the first couple of examples says rewrite each radical expression using rational exponents. The word rational is just a fancy way of saying it's going to be some sort of fraction. All right, so this one right here, the way that we read this is the cubed root of 5 to the 4th power. When we are writing this as a something with a base with a rational exponent, the radicand, which is the term under the radical sign, becomes the base of your exponent. So 5 becomes the base here. And then the index, which is the little tiny number that is kind of like in the little radical sign inside the check mark, that's the index. That is going to become the denominator of our rational exponent. And then the power to the radicand becomes the numerator. So the cube root of 5 to the 4th power is the same exact thing as 5 raised to the power of 4/3. That's it. That's all you got to do. All right, so just once again, this number is the power of the radicand. And remember, the radicand is the term that is under the square root sign. And then the denominator is the index, which is that little tiny number, kind of like the little like subscript of the radical sign. If you don't see an index, you have to assume that it is a 2 because it's the square root. So looking at part B here, we don't see an index. Sorry for the shadow. It's a little sunny in this room. So I know that there's a 2 there. It's the square root of 12 cubed. When I write this, the radicand becomes the base. The power of that radicand becomes the numerator. And then my index is always the denominator. So the square root of 12 cubed is the same thing as 12 to the 3/2 power. All right, looking at C and D look very similar, but they are very different. When you're looking at C, that negative is a separate term. So this is like -1 times the 4th root of 2 to the 5th power. D, the negative is inside the radicand, so this is the cubed root of -10 squared. So it's a little bit different here. We'll go ahead and do all 4 of these first ones just so you can see what's happening here. So when I'm rewriting this, I treat this just like A. It's almost exactly like A, just different numbers. It is 2 to the 5/4 power. Remember, the power of the radicand is the numerator, the index is the denominator. And then I want to make sure I write that negative sign on the outside. It is not affecting this 2 at all. This is just -1 times 2 to the 5/4 power. All right, D is a tiny bit different because that negative is now directly affecting the radicand. So when you rewrite this, that negative is inside the parentheses with the base, unlike what it was over here. And then we just have to the 2/3 power, right? My power becomes my numerator, my index becomes my denominator. All right, guys, question number 2, it's like the exact same stuff, except for you're just going the opposite direction. You're going from a rational exponent to a radical. Pretty much the exact same thing, right? We see negatives on the inside, negatives on the outside. So just to make a quick little note here, B is going to look very similar to 1C. See how the negative is on the outside here, the negative is on the outside there. So when we rewrite something like this, it just becomes negative square root of 7, right? The reason why it's a square root is my denominator is a 2, so the index here is a 2. You don't have to write it, but you can. And then the numerator becomes the power of the radicand. So you can write it just like that, or technically you can write it like this as well. You can write negative, and then you can do square root of 7 cubed. The cubed can either be on the outside of parentheses or it can be in the, I like to write it inside the radicand, but it's the exact same thing. Let's look at D. D is a little bit different. The reason why D is different is because my exponent is negative, right? My exponent is a negative. Anytime you have a negative exponent, you need to first make it positive. So the way that I make this positive is, if you remember, you just drop it underneath of 1. You put it inside of the denominator. this now becomes 18 to the 2/3 power, right? 1 over 18 to the 2/3 power. And then I can now rewrite this denominator using radicals. It's just gonna be 1 over top. My denominator becomes the index, so it's the cube root of 18 squared, just like that. You can leave your final answer just like this right here. All right, moving down to example number 3, we are going to now simplify this. We're going to get down to an actual numerical answer. All right, so let's look at A. First, rewrite this as a radical. We're going to use the index as a 4, and it is 16 to the 3rd power. All right, some of us, you might want to write this one like this, right? The 4th root of 16 cubed. Remember, those are the exact same things. The reason why I'm doing this is because if I were to not use a calculator, this would be a little bit easier in my head as opposed to doing 16 cubed and taking the 4th root of that. Here I can take the 4th root of 16 to get 2, and then I'm just doing 2 cubed to get 8. So I can simplify that all the way down to get 8. All right, looking at B, same exact thing, but be very careful. This negative is attached to the base, which means that negative 27 is going to be my radicand. So negative 27, my index is a 3, and that whole thing is squared. All right, so this is possible because I have an odd index. If this was an even index with a negative radicand, that's where you will see that no real answers or no real solutions. All right, so if I take the cube root of a negative 27, I get a negative 3. If I take negative 3 and I square it, I get a positive 9, and that's it. All right, let's pop down. Let's do one more together. Let's go ahead and do example E. Let's go ahead and do example E. All right, so first off, rewrite it. This is attached to my base, so I know that negative 64 is going in my radicand. If that negative was on the outside, like this one right here, when you write this, the negative goes on the outside of the root. So this one would be this right here, right? A little bit different, so make sure you guys are careful with that. Parentheses, negative goes on the inside. No parentheses, negative stays on the outside. All right, let's finish off E. My index is a 2. I know I'm taking the square root. You don't have to write the 2, but you can. And then I know I'm cubing this. All right, so since my index is an even power and I have a negative radicand, this is not possible. So I can just write no real roots. And then I'm done. All right, let's come down here to the bottom. This seems to be what is giving most people problems. So we'll do 2 of these. And then we will, I'll post this and then you guys can send this to me. Make sure you guys get this to me by Friday the 17th. Okay, so I'm gonna rewrite this using rational exponents. It's already in radical form. I wanna go down here and I wanna look at my different terms. So I have one term that is a number and my other term is a variable. I have to rewrite both terms or all terms in my radicand using rational exponents. All right, so the exponent of 27 is just a 1. So my numerator of my rational exponent is a 1, and then my denominator is the index, so it's a 3. So it's 27 to the 1/3 power, and then I have x to the 4/3 power. Remember, you take the power of the term in the radicand over top of the index. All right, then I just want to go back up and clean this up right here. 27 to the 1/3 power is 3. So my final answer is 3x to the 4/3 power. Final answer, that's it. All right, and then lastly, let's come down here. Let's look at example D. Let's do D. So I have 3 terms. I have a negative 8, I have an x, and I have a y squared. All right, so rewriting all of these, I have a negative 8 to the 1/3 power. I have x to the 1/3 power, right? There are no exponents to these, so I assume there's one of them. And then I have y to the 2/3 power. Last thing I want to do, I want to make sure that this guy is in parentheses. All right, last thing I want to do is I want to go through and see if I can clean up this number a little bit. So I'm basically looking for the cube root of a negative 8. This is possible because it's an odd index. If I take negative 2 times a negative 2 times a negative 2, I do get a negative 8. So the cubed root of a negative 8 is a negative 2. So final answer, negative 2, x to the 1/3 power, y to the 2/3 power. And then all done. All right, guys, I'm gonna post this. We just worked on half of it together. I do plan on meeting for Google Meet sometime tomorrow. I'll make sure to email you guys or post something in Google Classroom about exactly the time for that. So, all right, guys, have a great day. Bye.